All right, so we're going to look at solving some trig equations today. Now, to solve a trig equation, we essentially look at this. Cosine of x equals a half. Well, we want to know what values for x give us an output of a half right here. Well, there's going to be infinitely many values that we could plug in for cosine that would give us an output of a half, because we know cosine is oscillating between -1 and 1, and it is going to have a y value of a half infinitely many times. And so what we need to do in order to solve that cosine function is we need to look inside of its period, 0 to 2 pi, which is the unit circle. We look inside from 0 to 2 pi, we think about our unit circle, we think what values is our output a half? So you find those two values, and then we know it's going to be any multiple of the period from those values. So let's look at some situations. So we're looking at some basic ones right here where we only have one trig function present. So when we're seeing that, when we're only seeing one trig, whether it's tangent or cosine or sine or anything like that, the main goal we want to do here is we're going to isolate that trig function. We're going to isolate that and see what it's equal to. All right, now we'll get into more complicated ones that have have multiple trig functions, but here I'm going to try to get all the tans to the same side. So I'm going to subtract tangent of x from both sides. This gives me tangent of x minus root 3 equals 0. Add the square root of 3 to the other side. Tangent of x equals the square root of 3. So now we have to think to ourselves, we have to remember our unit circle, we have to think, when is tangent the square root of 3? Okay? And remember, tangent's period isn't all the way to 2 pi. Tangent's period is just from 0 to pi. So we're thinking from 0 to pi, when is tangent going to be the square root of 3? Well, of course, it's going to have something to do with those 1/2 square root of 3 over 2 points. And so if we take tangent sine over cosine, square root of 3 over 2 times 2 over 1, well, that gets us the square root of 3. So I believe it's that point right there from 1/2 square root of 3 over 2 is that one point within our period from 0 to pi, because we know it's just going to keep repeating with tangent every pi. And so it's that point. What creates that point over a half up square root of 3 over 2? That is pi over 3. So tangent of pi over 3 gives me the square root of 3. And it's every multiple of pi. Not 2 pi. Every multiple of pi where n is an integer. So, again, we were looking to get tangent by itself. We're thinking about, okay, what values for tangent give me the square root of 3? There's infinitely many of these values, but I look for just one of them within my period from 0 to pi. I found that one value, pi over 3. And so to express it as all the values that would possibly give me the square root of 3, I know it's any multiple where I add the period to my square root of 3. As long as n is an integer, then I know this is going to give me an output of the square root of 3 for tangent. Now notice still right here we only have one trig ratio that we're dealing with. We're only dealing with sine. So I'm going to isolate that. I'm going to subtract 1 from both sides. Still have 4 sine squared x equals 3. Divide by 4. So sine squared x equals 3/4. if I take the square root of both sides, sine equals positive or negative, so we're taking the square root, square root of 3 over 4. So let's simplify that down. That would be sine of x equals positive or negative root 3 over 2. So think about when sine is positive or negative square root of 3 over 2. Well, positive square root of 3 over 2 we could get with pi over 3. We could also get positive square root of 3 over 2 at 2 pi over 3. And then negative square root of 3 over 2 we could get at 4 pi over 3. And we could also get negative square root of 3 over 2 at 5 pi over 3. So I'm thinking back to that unit circle, I'm evaluating that out. And then to express this as any interval of this would be pi over 3 plus 2 pi n, because I know that for every multiple of my period after this, it's going to have that same exact value. It's going to have that same output of positive root 3 over 2. Same thing here. So that'd be 2 pi over 3 plus 2 pi n. I need to do the same thing here. That would be 4 pi over 3 plus 2 pi n. Finally, 5 pi over 3 plus 2 pi n. Of course, in all these situations, n is an integer.